Alright, so what I'm going to do in this video is try to do three big things. And the first thing I want to do is talk about what is sigma in terms of its setup. And then I'm going to build out some terms to show you what that would look like. So build out terms. And then the third and final thing is I'm going to translate those terms into equations. So we'll break down what those two things will look, or what the equations are going to look like here. There's going to be two big ones in two categories. So there's going to be an equation for just a single term as well as an equation for the sum of those terms. So let's go ahead and come up with an example. First of all, this sharp-cornered E is the Greek letter sigma. It stands for sum. So we're going to use this to represent that we will be adding together terms. Specifically, we're going to begin with, in this case, the first term. So this number down here is going to tell you the position term to start with. So when we add these terms together, this is going to tell you to start with the first positioned term. So in this instance, first term. And then this number up here, I'm going to go up to 5. This is going to tell you the position term to end with. So in this particular example, you're going to end with the 5th term. And then finally, the last piece that we need to understand sigma is a rule. And that rule is going to tell you how to build or how to create these terms. So a rule of construction, that's what I'm going to call this, for terms. And I put parentheses around it, that way we know that where the parentheses open, that is the entire rule, and where the parentheses close, that's the end of the rule. Sometimes these rules can get a little lengthy, so the parentheses will help us to know what the rule is. So I'm going to recreate this example, 5 sigma n equals 1, and I'm just going to do 3n minus 8. So this breakdown tells me that I'm going to start adding together when n equals 1, and then I'm going to go all the way up to when n equals 5, and the rule will be 3n minus 8. So each time I'm going to be plugging in n equals 1, my first term, 3 times 1 minus 8. And then the last term will be 3 times 5 minus 8. And then in here in the middle, where we don't really have room to fit it, that's where we're going to have, okay, n equals 2, n equals 3, n equals 4. So all of this goes together to say 3 times 1 minus 8, 3 times 2 minus 8, 3 times 3 minus 8, 3 times 4 minus 8, and then 3 times 5 minus 8. So the setup for sigma is very straightforward. You begin with this position, you end with this position, and then you use this position number in the rule to create your terms. So this example here is going to come down to be 3 times 1 minus 8, negative 5. 3 times 2 minus 8, negative 2. 3 times 3 minus 8, 1. 3 times 4 minus 8, 4. And finally, 3 times 5 minus 8, 7. So from this single condensed format, we have 1, 2, 3, 4, 5 terms, and together they are going to add up because sigma means sum, so add, 2, negative 5 plus negative 2, negative 7, plus 1, negative 6, plus 4, negative 2, plus 7, 5. So that is the setup for sigma, and it's a little bit of how to build out terms. So I'm going to pause here and I'm going to restart the video after a brief intermission.